Hi guys, so today I'd like to give a short introduction on how to set up your own Git repo and how to make an own remote just locally, for example, on another hard drive as a backup. So first of all, we have to set a few things clear, namely that Git and GitHub aren't really related, so I guess most people nowadays will hear of GitHub before they even hear of Git, but in fact Git is much older, like maybe from beginning of the 2000s, and was actually software Linus Torvalds, the guy who wrote the Linux kernel and who's still its main developer, wrote just as a means of coordinating its cooperation with other Linux kernel developers. And yeah, Git itself is a software for version control. Version control means just making a series of basically reconstructible carbon copies that enable you to just get back to previous versions of your same document you're writing, so that you can compare, and maybe if you've changed the draft, you can still get things back you deleted and only has in a former version of a draft. And Git is also much more than that, because it's aimed at collaborative projects where a lot of developers are developing at the same time and everyone's working at his own sub-project, and in the end they try to merge all their new codes into the main branch of a project. So this is what makes Git a lot more complicated than it would need to be if it was just a basic version control software. So there are also other version control softwares, such as Subversion, for example. But Git has basically become the absolute standard. So it's definitely useful to learn it, even if you only try to do basic things. And yeah, the thing that's important to know about Git is that because it's written by Linus Torvalds, who's a great open source advocate, it's also free. That's to say, libre software that respects your freedom. And this means, for example, that it doesn't include spyware or other shady things, and everyone's free to alter it as he pleases. And it's mostly used via the command line. So just on the Linux command line or Windows, you can either use the standard CMD command line or PowerShell, where PowerShell is much more user-friendly in my opinion. And GitHub, on the other hand, is a completely separate project by completely different people who have, as far as I can tell, nothing to do with the actual Git developers. And GitHub is basically a website like Dropbox that just lets developers host a lot of stuff, and it's targeted specifically at developers and organized in such a way that everything that's uploaded gets uploaded to a Git repository. And GitHub has a lot of functionality on its website that's basically just the front end for Git. So basically everything you do when you go to GitHub to work on a repo, you can just do as well with a basic Git command line utility. And GitHub is, well, free as in it doesn't cost a thing if you just want a basic free account, which only allows you to create public repos or private repos that are only for yourselves. But if you want to collaborate with other people but don't show your source code to the whole world, you have to pay the money to get a pro account. But no matter what account you choose, you should be aware that Microsoft, who is the owner of a GitHub company, uses all that source code to train their own code writing AIs. So every piece of code you write or have written will end up somewhere in the neural networks of Microsoft's AIs. So that can be kind of dangerous when you're putting private stuff into your repo, because if someone else is using that AI, by the way, one AI product they offer on GitHub itself is called GitHub Copilot, and it seems pretty useful, just basically a very advanced auto-completion software for your code. But if someone writes something like, hey, I'm Mr. So-and-so, and my password is, and then lets the AI complete it, and if your password was in the GitHub training data somewhere in the repos, then it's very possible that your password may be produced by the AI. So you should definitely make sure that you never ever load up any files that have passwords in it up to GitHub. So yeah, but today, we just want to focus on Git, and well, let me just show you how Git works. So let's say I want to make a new Git repo, so just call it repo. I'm doing this on PowerShell, but basically everything I do should also work the same on the Linux, in the Linux shell. So for example, bash or zsh. And now, let's just take our files we've written and put them in the repo. And now what you have to do is, first of all, you have to just init the Git repo, just like that. And what you can now see is, okay, maybe you don't see a thing at first because you only see these two files if you don't have the hidden hide files function activated. But if you do, so for example, in Windows Explorer, if you've put the check mark here, you'll see that there's a Git folder, which basically contains all the extra data that Git saves regarding former copies of your files, etc. So if you delete that folder, it would be just the same as if you've never made that a Git repo for this folder. And now, first of all, we have to add all the files we want to put in our Git repo. So we have to tell Git what files it's supposed to track. And let's say that it's supposed to track the git.txt file. Then we just write git add git.txt. And now we can try to commit it. So this works basically by the git commit of a git commit function, but and now if we've committed, Git wants us to give every commit, so basically every part that, like basically every checkpoint we make for our source code or our documents, it wants to give us a short description what we've made. So of course, since this is the first commit, we could just write basically like something like first draft, but in general you would try to write something that's more descriptive in case you really care about finding specific changes when you go back to former versions of your document. So for the time being, just write anything, and let's just save that. And yeah, so basically this is the workflow for keeping checkpoints of your documents in your repo. But if we want to make a backup somewhere else with Git, we have to use the Git remote functionality. And so first of all, we need a bare repo somewhere else. So let's just make another directory, which we call backup, or maybe remote would be a better name. And now we have to add this remote, and we have to give it a name, like usually origin is a pretty standard name, and at least it's a standard name. GitHub would give the copy on their servers. And now we just write the name of the folder we created, and in this folder we have to initialize a bare repository. So you'll see in a few seconds what the difference actually is. And now let's get back to our repo. Now we just push our comment. Yes, we have to first set our upstream repo. So in this case, it's just our repo, which we call origin. And it's supposed to be the master branch, the main branch. And yeah, now we successfully made a backup in our remote folder. So let me just show you the remote folder. So it basically contains everything that's inside the Git folder itself. So just let me show it to you. So that's basically the standard structure of the GitHub repo, and that we see here, it basically looks the same with .git folder. So this is how you make a remote, but you see you can't really directly find the files we've created inside here. So basically pieces of those files are saved somewhere here under those hashes, but all these files are compressed, so you won't see anything you can recognize as your original source code. And for this reason, if you want to have a backup, which you can read just like that, you can just clone it. So let's just go to our backup folder, and now we just do git clone, and yeah, let's just say we take the remote folder for that. And now what we've cloned is a folder which is also called remote, because that was the name of the folder. And if we look inside, we see our file git.txt. So the only file we've added to our Git repo. So remember that we didn't add the other file, which we've got somewhere here, because, yeah, well, we didn't add it. And so it's not tracked, so it won't get synchronized to other. Right, so by the way, now once you edit those files, you can do the commit procedure a bit faster. So would be m argument, you can just write your commit message on the command line. So just write anything that's like at least one character if you don't really care about your commit message. And you can also use the A flag to say Git that it's supposed to put every file that's tracked and that has changed since the last commit into your new commit. So usually you want to write something like this. And in this case, nothing happens, but it gives us a warning that we didn't track github.txt. And if you want to suppress this warning, you can make a file called gitignore and just write the name of a file you don't want to track into that gitignore file. So now that I think in this case we still have to add the gitignore file itself, and now if we commit, we don't get a warning anymore. And commit means just that the .git folder inside this folder has been updated, but nothing has been written to another repository. For that, we have to do git push, and now we can save the set upstream origin master argument. And just like this, it works. And now, if you want to update your backup, you just do, so inside our backup repo, you just do git pull. So yeah, that's basically it. So if you look, you see there's now also the gitignore file in our backup repo. So yeah, that's basically it. So ask me if you've got any questions.